Let's see if this thing is working. It's rolling, it's rolling. So, okay, first about the presentation. So, detection engineering and use case design kind of intersect, at least in the last couple of years. Oops, I forgot my fucking remote, naturally. Here we go. So, a little bit about me. If somebody's asking me what do I do, and even my relatives, which are, by the way, crazy anti-vaxxers, I kind of say that I construct mouse traps. I make mouse traps to catch mice. You know, that's the main idea. You kind of build stuff that alerts on some behavior. That would be a detection. Hence, detection engineering and use case design. So, this is what I do. I construct mouse traps. Now, I'm not going to go employment history and all that jazz. Quite frankly, it's boring and nobody cares. So, currently I'm involved in the basically compliance purview stack, which has a lot to do with use case design. And pretty much the approach that we are going to go over can be used to any security system, really, to design any custom detection that you might need. And that's kind of the basics, right? So let's start rolling. So what is detection engineering? Detection engineering, the main goal, if you have to distill it down to I have to do this, is basically you have to derive meaningful security alerting from the data coming from your devices, right? So you're going to have logs. They're going to come out of everything, firewalls, endpoints, your EDR, your email gateway, whatever. And this thing has to be derived for some pretty much actionable alerts that your SOC or you or the admin guy or whoever basically can act upon. You know, you need to track intrusions or changes in posture, whatever it's kind of whatever the business need of the company you are in it. So you have to distill it down. A use case is a cybersecurity use case would be something that the business needs to monitor in terms of either being compliance or being breach alerting, whatever you have over there. So this is kind of the basics of the operation. And pretty much you guess what you're going to look for, then you write certain code that is going to facilitate that particular, looking for stuff in automated means, because you cannot do it always manually. Benefits, obviously, if you have a good detection engineer, they can tune your rules, your CM system, your EDR, whatever, so your SOC is not going to die out of flood of alerts. If you have good detection engineering team, obviously you're going to spot the things faster, because quite frankly, there is nothing like matching a detection to the certain environment that the client has. While solutions come with something out of the box, this is customized for billions and billions of people. And just a little customization transforms the efficiency from, let's say, 20-30% to about 80 to 90%, detection ratios of threats that you might miss. So it's kind of beneficial. And also when you control your rule set, you can pretty much control everything in the vertical, from the detection to the actual response to what detection you want to weed out or what you want to look at. When you buy something and you take it out of the box and you implement it, that thing is not possible, quite frankly. So, this is what detection engineers kind of do. Okay, to be fair, most of the times we just whack false positives because the SOC is dying, but hey. All right, so what do you need to start detection engineering, right? I mean, you want to do detection engineering, you got to do some prerequisites before you start rolling. First, you want to do log survey. So what is log survey? So you're going to sit down and you're going to think what you have in your environment, firewalls, endpoints, whatever is available, and you're going to figure out if those logs, are of some value to your specific monitoring needs. Like, obviously, the mail server is going to be kind of a value. Your endpoint logs, whatever you got, but you kind of survey the whole picture and you build a log inventory, right? So when you build a log inventory, you have kind of starting point to figure out what you have and how you're going to use it. Log collection, it's a big one. Many companies are actually, this is an ongoing process and it's constantly ongoing. Log collection means you actually build an infrastructure to ship those logs from those devices to a centralized location. So, hold up, I think I ran log survey and collection. No, I'm here. All right. So then you got your use case design that comes in. You figure out what you want to detect. You want to detect, for example, file put in the wrong folder. You know, your guys, for example, are working in a specific folder, your programmers, and certainly an executable file ends up in another folder on the server. Something is going on. You want to look at that stuff. Then you're going to figure out your detection logic. So the detection logic would be pretty much, you got the logs. Now you got to figure out how to, you know, basically in automated way to go over these logs. I mean, you got to have something there running to produce meaningful alerting, you know, something that is actionable and something that you can give your SOC or your engineers or your admin, whoever, but basically, you know, you got to have some sort of criteria to weed out those events that are of value to you in terms of security monitoring or compliance monitoring or whatever you want to do. And then you're going to have your response workflow. So this is important and many people overlook it, but if you see that the red light is blinking, then what the hell you do, you know? When that red light blinks, you gotta have some sort of a process to respond, or chaos ensues. Servers get encrypted, then the backups get encrypted, and you're out of business. Those things are kind of interconnected. You cannot have, obviously, detection logic without shipping your logs. So there is that. They're kind of a iterative workflow that you constantly work on and improve. So, you know, some key questions that you need to answer is basically where your logs are coming from. Is your collection working properly? Do you have gaps? Like, do actually you lose logs? For example, some log shipping systems go down and nobody gives a hell because they're not under monitored, and your log flow goes down. Obviously, your detection pattern will not see stuff because stuff is not coming. So, apologize. Okay. And these, obviously, do you have the right data? You might be over-collecting, you might be under-collecting. So am I gathering the right logs? I mean, for example, let's say you have the logs from the door entry system or whatever, and you want to monitor, I don't know, for example, who is going on stage. That's not going to give you, I mean, it's going to give you who comes into the room, but it's not going to give you who goes on stage now, will it? How long? What's your attention? So let's say you have, you know, you need to do detection logic and you have only 72 hours of log data, but you need to correlate across, for example, a week of events. So you got to know your constraints and how long are you keeping that data, or you're going to go, obviously you're not going to be able to realize some specific detection, you know. Common log sources that you want to look at: user authentication logs, email systems, firewalls and network devices, cloud services, database, application. All of that is of value if you have, you know, the right detection to attach to it. If not, you're just wasting money on pretty much log storage. So, kind of the basics before you start rolling anything is, you know, if you need to design a use case, there are some basic elements that even before you start rolling, you need to have an idea, let's say. So obviously, you're going to name it something. I mean, that rule is going to be named something. It's going to come into the SIM. So kind of important. Purpose. So what are you trying to detect? What are you trying to see? How does it actually work in your specific environment context? Problem statement is clarification on the purpose. So problem statement is you actually describe in detail what you want to see, what you want to detect, or what you want to basically, why are you doing this for? Data sources, this is important. So every detection that you design is gonna depend on some data sources. Basically the data source is a system that is issuing logs or something, you can call it a sensor, that is providing telemetry based on which you're gonna make decisions, right? This is gonna be your data sources, where your logs are coming from. Then you're gonna have your detection logic. How are you gonna detect? How are you gonna see? What is gonna be your detection rule? What is gonna be the syntax? What is gonna be the false positives? What are gonna be the false negatives? And all that criteria that is important for you to process further. I mean, this is where the core of the magic happens. This is where you produce the alert. This is the actionable event after this. And you're gonna have your response action. Response actions are, like we said, the red light blinks. What do I do? This is important. If you're one guy, doesn't matter. 2, 3 guys, a company, doesn't matter. But when you have a SOC that is distributed, let's say, in 4 freaking countries, and you want to get them on the same page and they respond to a certain standard, you want to have consistencies between basically what's going on, then describing the response actions becomes very important. All right. So there's a little bit more of a extended, let's say, this is what I use for a template to start working on every use case that I kind of have to deploy. So obviously you got your, we spoke, name, purpose, problem, business impact. This is an important one. When you roll your detections, what will happen? Because for example, if you push a detection to the EDR, and depends on how this thing is rolling, you might slow down the endpoints. Or when you need to ship the logs from your email servers, you might clog up the network. Or, I mean, basically you have to figure out when I put this in production, what happens. So data sources, we spoke about this. Detection logic, we spoke about this. Response actions, kind of, specifics. Like I'm gonna rotate the credentials, or I'm gonna reset the password, or I'm gonna quarantine that endpoint, or I'm gonna block this mail sender, whatever it is. You wanna have your response actions. And then you're gonna have assurance metrics. And this is often overlooked. The assurance metrics says basically how, if I deploy this, what do I need to say, or what needs to be matched or met as a criteria for my detection and my use case to be considered successful and something that is worth running, because quite frankly, running custom detections costs money. It translates directly to cost. You onboard logs, you process those logs, you have computation that is running, so this translates directly to money. So if you gotta justify to the business, why am I doing this? So you can say, for example, 5 minutes for detection of a specific event that it's in the use case. So those are your assurance metrics, and they kind of serve the CYA scenario, which should be cover your ass. Okay, so we're gonna go over a case study, detection of a suspicious OAuth application access. This is kind of it's been a thing in the last couple of years. Basically, the bad guys will send a phishing link with authentication, not authentication, but actually a link to an application that authenticates against the environment, and they kind of get a persistent access to the user mailbox, or God forbid, if admin actually gets phished with an application, they get even more. It's persistent, it's nice, it lives directly into the Azure AD tenant. It gives you, basically everything the user has access to, and it's often overlooked because, quite frankly, people don't look there. If you're using the Microsoft security stack, and specifically MCAS or other CASB solutions, they monitor specifically for this. But to be fair, first, people don't implement MCAS because it's kind of something hard to service on the back end in terms of you need to process the telemetry from it, and you need to have analysts on it because this thing produces a lot of noise. And second, it's actually expensive. So, that basically how the flow works. Attacker creates a malicious app, user restricting to approving permissions. Attacker gains persistent access. This is where they sit. And they basically exfiltrate data for more or less, They sit over there pretty and they're stealing data, which kind of is the end objective in this case. So the nice parts about it is bypasses password authentication. You don't need to fish any more passwords. You got an application over there, it sits there until somebody removes it. Activity could appear very legitimate. They can have a tenant, they can sign their application, all that jazz. FireEye got compromised exactly, I believe, with some sort of application like this. Yeah, users don't understand what the hell they're approving. Phishing links, they're kind of they're on the lookout, but like when it's an application, do you want to approve this? And you get like a legitimate Microsoft window that says, hey, approve this, and they click it. Okay, so what are you gonna do in this type of situation, right? So your core components, obviously, you're gonna name your use case suspicious OAuth application consent. Purpose would be to identify potential malicious OAuth grants. Problem statement. OAuth phishing enables persistent access. Basically, they get in, they stay in. Business impact, well, they can read mailbox, they can read whatever they have access to, and they can do even more damage. So your data source would be Azure AD audit logs. Detection logic, basically, you're going to look for high-value permissions and non-approved applications. Response would be to revoke the application access to the credential if that happens. And for example, for assurance metric, you're going to have, let's say, 5 minutes detected, 15 minutes triage SLA. So upon 5 minutes of registration, you want to catch that thing, and you want to, in under 15 minutes, you want to get it out of your environment so nothing bad happens. That's your objective to do. All right. So for detection response, how would the flow would look like? Alert would be created in whatever monitoring system you have. Security team will be notified by this set alert. Obviously, the SOC is going to have some investigation to do. Is it legitimate? Is it illegitimate? Whatever is going on. And then they're going to decide on action. Are they going to follow their response process, what we outlined in the beginning, or they're just going to, scold the admin for approving something? So, obviously, what happens? It's a little bit of an if-then logic. If it's a confirmed threat, you're going to block the access, reset accounts, investigate the impact. If it's suspicious, temporary block, and then verify with the user. And if it's false alarm, obviously, yes, you're going to close it as a false alert. So, what you're going to need, every time you start, you're going to need some validations that you can actually pull it off. So, is the logging infrastructure in place? Is your log source connected to your detection system? That would be, in this case, the Azure AD logs have to be connected to your SIEM, being Sentinel or whatever is going on. Then you're going to develop some detection rules. They are going to look for, that particular activity in the logs you have onboarded. And then you're going to establish your response procedure. You're going to, like I said, rotate credentials, whatever you want to do. And you're going to deploy monitoring controls, which will pretty much, you're going to look for that specific behavior, and you're going to instruct the SOC on how to operate, what to do. So validation, basically, okay, so we created this use case, we created this monitoring, and you're going to do some, you're going to do some validation before you roll it out in production. This is your basically your basic sanity check. You're going to have test, did it happen? Like roll it against data that has been already kind of collected. What's your false positive? Basically, what are the ratios of noise versus what are you actually getting in terms of valid alerts that your SOC has processed and stopped? You're going to do some measurement before you roll it out in production. You're going to document your false positive patterns. When it generates false positive, what happens? So, future processing, people have some sort of a guideline in order to do this, and you're going to try to minimize it before you roll it out in production, at least against the data you have at the moment. And you're going to validate your response flow. Can you actually ban the application? Can you reset the password? Can you rotate the credentials? You need to validate that before it happens. Because there's nothing worse than you create, for example, automation app that resets password and this thing is not working. Trust me, it happens. All right. So, this is kind of my last slide. If you have to boil it down to 3 or more stuff that you basically, you want to say, okay, what's going on here? You're going to, number 1, know your data, know your sources, know what the hell is going on. Define your threats. That would be the threat modeling people, if there is anybody here. You do a good job. You have to figure out what's your threat and who's going to attack you and how this is going to look. And always attach a response process to your detection pattern. Basically, always have a response process that is attached to your specific detections or your specific detection logic that works. And this has got to be written, and people, stakeholders, it's got to be burned in, contacts, all that jazz. If an incident happens, what the hell you do, and how if 1 a.m. in the night, you get a call that you have servers going offline at the ratio of 3 per minute, and you're losing connection to your endpoint, what the hell you do? So, yes, this is actually the last slide. I'm going to show you a document of this kind of being in action. Basically a kind of a designed use case that you can pretty much, I'll put it on GitHub, so you can work with it. And I don't know, question now or later? What's the, yeah. Okay, so I'm gonna just roll a bit another document that I've designed. And my wife said to keep out of the presentation, thank God. By the way, that's my wife, and she's been putting up with my assholishness so I can create this. It's not going to be a demo. It's actually just a document. There's no, come on. You do demos on a company laptop now, will they? Okay. Do we got some motion? Okay, we got some motion. Yes. So this is how a proto use case would look like. This needs more work. So you got your name, detection of an authorized application, access to Azure ID. You have your purpose statement, detect authorized application, consent. Okay.
Не се вижда обаче.
Бага ми.
Трябва да го екстендната екрана, трябва да го слайднеш.
I apologize. I suck at this. Which way? There we go. There we go. So probably if I press F11. All right. So since I cannot see shit, I'm gonna go here. So you got your purpose. You're going to detect unauthorized apps. You got your problem statement. What the hell am I trying to detect? And basically, why am I doing this? You're going to build your success metrics, technical success metrics, what we spoke about. For example, detection latency under 5 minutes, alert to incident conversion ratio. That would be 80% of things would be noise, and false positives under 15% of the produced events. Mean time to respond, let's say until you detect this to a remediative action, you're going to aim for 15 minutes, and that's on your SOC. So obviously this is going to be it's going to be a high severity type of alert. Detection requirements, this means what do you need to detect this? So you're going to monitor your Azure AD OAuth. You're going to alert on application requests with sensitive permissions. You're going to alert on applications from unverified publishers, and you're going to alert on recently registered applications 30 days ago. That's not actually very good, but alert on applications not approved in application registry. Most companies have an application registry of applications that they use for their, let's say, applications that integrate with Azure AD for authentication. So they keep kind of a registry, basically the enterprise apps in the Azure AD portal would do that for you. All right, I need to scroll down, I guess. Okay, can somebody come and scroll? Brilliant. Thank you. All right, chill. All right, so this is where it gets funny. You got your primary source, reference data. Obviously, you want to create like a whitelist of applications, and then the analytics rule query. Now, this pile is actually the main magic, and honestly, if I try to explain it now, it's going to be probably about 30 more or 40 more minutes, plus some KQL basics. But this is what runs in the sim. Yeah, this is what's going to produce the alerting. This is what's going to scream. This is what's going to. Could you This is what's going to produce the prioritization and pretty much generate the alert and prioritize the what's going on and how bad is it. Let's put this is a detection rule. It's kind of the most what I usually do. So I'm going to scroll down a bit. So I have basically a pseudo code. So if somebody shows up and they're like not exactly versed in KQL, you want to be able to kinda explain to them what's going on. So you create some sort of pseudo code if-then logic that they can follow, like a normal person can read. And you put it under your detection, under your KQL. Why do you do this? Quite frankly, sometimes people go in and they edit detection rules, like those things are alive, but they don't update the documentation. And it's difficult to follow what was the original intent of the person who wrote the rule and why do they have it in the first place. So
There is not a reset button.
I apologize. So a little bit more. Thank you. Okay, here we go. Good. Okay. So technical components. This is what you need to pull it off. Azure AD audit logs. Microsoft Sentinel Analytics rule. Obviously one created over there. Sentinel watch list that you're going to put your whitelists in. And if you want to go one step further and you want to do automatic response, then you have Sentinel playbook for automatic response. Yes, there was a certain Ilyan over here that kind of does this. All right, so you're going to calculate risk. Obviously, risk score 40 to 74. Why is this important? Because many monitoring systems, Splunk, Azure, every one of them kind of use event compounding to calculate risk. Meaning, if something happens, it gets a value of 5. Then something worse happens, it gets a value of 10. But let's say the alert threshold is somewhere around 30. So you get a bunch of stuff that has to happen in a block in order for an alert to be raised. So you're going to have your, basically your score compounding and risk accumulation. And this is important because without risk accumulation, your SOC is going to die out of alerting. Let's say if you have alerting based on atomic criteria, what would I call basically, let's say, an IP address or a string, and you don't have any risk compounding, then you're going to produce lots of events, and this will swamp the SOC more or less. So if you can go down. Okay, thank you. And you got your technical dependencies. What do you need in order for this to be swing? Technical limitations. What are the limitations of your actions? Like, I cannot do this because, or I cannot do this. Where are my limits? And this, it's a little bit, let's say, not fleshed out here, but you really need to dump a lot of stuff in here to cover your bases. Why something didn't work? Because when the auditors show up and you got to say, they go, well, why didn't you detect this? And you can go back to the limitations and say, we didn't detect this because blah, 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 blah. MITRE mapping. People use kill chains, MITRE mapping. You want to put it somewhere so it can be classified and basically for you to have an idea where your detection is covered and where it's not and where you need to work. And maybe, if new threats arise, you can use the mapping to kind of refer to your current detections, and maybe you can just tweak this one to go after the new threat. You got your configuration requirements, basically what do you need to configure in order for this to be swung. And that's it. And pretty much, that's how would basically a skeleton of a use case for detection would work, or how it would look if I do it. Now, people have their approaches. They have different stuff to do this. So, yeah. Questions, comments, anything, guys?